Hello and welcome to another video in the How Do I Do Something in CloudBolt video series. My name is Mike Bombard and I'm one of the cloud architects on the pre-sale side of the house here at CloudBolt. And today we're going to be discussing how do I use Terraform Operations in CloudBolt. So let's talk about Terraform a little bit. CloudBolt, this is a recent release. We've recently released what we call Terraform Operations. It's our third version of working with Terraform inside of CloudBolt. There's really 2 points that I want to draw out here. Is number one, CloudBolt wins with Terraform. And the big reason here is that anytime you need to add new content to the catalog in CloudBolt, we are the most extensible cloud management platform on the market. It's easy to extend with CloudBolt. I have yet to run into anything that I can't do in CloudBolt with the extensibility that we've built. However, I also want to have accelerated time to value in a lot of cases when I'm working through these things as well. So if there's something new that I need to offer in my service catalog that is another cloud-based resource where there's a Terraform provider already available for that cloud-based resource, then very likely I'm going to start with Terraform simply because it keeps me from having to write all of the API calls to those systems and the backing Python code needed to make those REST API calls. So it helps me to get new content into the CloudBolt catalog quicker and enables me to effectively get new workloads out to the user base quicker and reduce the time to response that is needed to get those new catalog items out there and available. I would also say that Terraform wins with CloudBolt as well, though, because when CloudBolt serves as a front end for Terraform, your cloud-based resources that are deployed with Terraform, they can be funneled through the same organizational standards that we're sending other catalog requests through. Maybe we need to route a request via ServiceNow to create a service catalog request, and that follows an approval process. CloudBolt, when you've defined an approval workflow or an approval pipeline inside of CloudBolt, any of your catalog items that meet that criteria will still continue to go through that approval workflow. So it enables us to standardize those processes inside of our organization to ensure that we're following the appropriate ITSM guidelines that have been set for or by the organization. So the other thing that CloudBolt gains you is the ability to easily reshare those Terraform configurations. Presenting it as a service catalog item, just as an example, we can help to intelligently drive in the appropriate values for Terraform variables so that your end users aren't out there trying to hunt down the appropriate AMI ID and then make sure that they selected an instance size that's valid for that class. We can bake that intelligence into a service catalog request so that your end users have a more streamlined user experience. So a lot of the big reasons why we went down this road, why we've chosen Terraform to serve as one of the infrastructures as code that we support. As part of this call, we are going to be covering off these Terraform operations. We'll go through a brief introduction. Then we're going to talk about how do we set this up in your environment. We'll get into updating and adding new Terraform versions to your CloudBolt instance and some of the enhancements that we've made around that. We're then going to get into resource types and setting those up and how they work a little bit differently in version 3 of the Terraform operations. Then we'll plug into a Git repository. We'll talk through creating those Terraform operations and doing some live examples, attaching environments, and then we're going to get into working with variable maps. So that's the agenda for this video. Let's go ahead and get started. We are going to start with a high-level overview of the updated features in the Terraform operations. We're calling it V3, but really this is the third iteration of leveraging Terraform inside of CloudBolt. So the first thing that I'll call out in the video is obviously the documentation. If you go to docs.cloudbolt.io, on the left-hand side, you can search for Terraform. And specifically, the documentation we're looking for is Terraform integration through CMP blueprints. You'll notice a header here is Terraform Operations V3. This is kind of the starting point for getting started with Terraform Operations V3. I will point out that we're talking specifically through changes that are made in 2023.3.1. If you're on a version that's later than that, things may have changed somewhat. This is the beta release for Terraform Operations v3. So the first thing that I'll point out is this is hidden by a features flag. So you will not see Terraform Operations until you've gone through and run this. And we'll walk through how to go through that process here in a later portion of the video. But it is hidden by a feature flag because we want to give our customers an opportunity to make sure that Terraform v3 meets all of their needs before they're exposing it as part of their blueprints. We want to make sure that this is a purposeful and valuable move for our customers to move forward with additional changes and things that we've done with Terraform. So start with the documentation and then just a real quick high-level overview or some of the highlights of the updated features in Terraform Operations. In Terraform Operations, and we are working through a plan to go through and get everybody on Terraform Operations. These are extremely powerful. There's a lot of changes we've made into the covers. You'll notice that if you're in CloudBolt in 2023.3.1, there is still the action and Terraform plan. There's also the Terraform button itself, but really what we're looking for now and really the way forward for Terraform inside of CloudBolt is leveraging a Terraform operation. So look for deprecation plans for these other two functions over the next coming releases. We want to make sure that we're on a good stable version and we can continue to iterate and drive the product forward with Terraform Operations. So the first thing, you will not see Terraform Operation enabled until you've started with that feature flag. Again, we'll run through that here in just a little bit. It looks and feels very similar to the past versions of Terraform, where we will show, and in this particular example, we're pulling in from a source control repository I have in GitHub. It's pulling in the files that exist in that directory. One of the first changes that I will mention, we still allow environment mapping, but one of the biggest things that we've done with this update to Terraform inside of CloudBolt is allow you to configure what we call variable maps. And you'll notice that in this particular blueprint item, I have two variable maps that we're calling here. One is called AWS to Terraform variable map. This is an out-of-the-box variable map. There's also one for Azure. What this is, and we'll show you this here in a little bit, it's just, it allows a JSON formatted payload to define what CloudBolt parameters we're going to leverage to drive values for as far as like environmental variables for Terraform. So AWS to Terraform actually pulls in the AWS access key and secret access key and kind of slipstreams it into the execution as we're running things by passing a command line argument and when we're executing Terraform. So we'll show that here in just a little bit. So this is my authentication piece. The next piece is my website inputs, or this particular Terraform config I'm using in this blueprint is creating an S3 bucket that has a website enabled, and all of my inputs for this, or my variable maps, are declared inside of my S3 website inputs variable map. So this is the big thing. This allows us to be repeatable in nature. You can have one or more variable maps declared in a build item inside of CloudBolt, and this allows us to reuse this across blueprints. So if we have a common set of inputs for maybe S3, we can create one variable map, share it across all of our blueprints, all of our Terraform enabled blueprints, and that would allow us to, again, share and reuse this content. So you can be a little more purposeful in how you're creating variables and controlling those inputs. The other thing that I will point out, we still do allow you to attach environments. Now it's a slightly different use case. We will still leverage the underlying resource handler credentials to communicate to AWS when we're leveraging that attached environment. But we also, we no longer require you to do that variable mapping here at the attached environments level. So if you went through that in the last version, we used to have this screen. We can still predetermine variables that we're using inside of our variable map here. So if you have variables that are defining your environment, maybe they have dynamic dropdowns defined, those types of things, you can still predetermine a single value from that environment if you wanted to pass it into your Terraform config, but you don't have to. So that's really what this is for here. And then after we go here, this is really done at this point. We don't have to go through. Before, it was a process where we had to map every single variable for our Terraform config or our Terraform scripts into those attached environments, and the parameters had to be on the environments. That's now a thing of the past. Again, we'll dive into that a lot deeper as we get into this. The last thing I do want to show is just what those variable maps look like. Again, real high level. take 5 or 6 minutes to run through all of this. But then variable maps is the other big thing. So you can see here where we are leveraging Django templating. These are just JSON formatted payloads that define a Terraform variable and its corresponding value based off of either Django templating. These could also be just a static string. So if you automatically wanted to say for this particular use case, like S3 website inputs, I could just put in, maybe this group is always for my IT group. I could swap out the group there and just do double curly brackets, just a string with quotes around IT. So passing in static strings, these can be dynamic. These can pull from other places. This would also allow us to pull maybe outputs from one Terraform config and use those as input variables into a second one. So a lot of flexibility is inherent in the way that we've defined and designed this. So this is kind of the overarching big idea. The other thing that I will point out that's really handy is the execution itself gets a little bit easier in the new version, or the end user experience, let's say. This S3 website, just as an example, I did select an option. I didn't point this out yet, but one of the things that we have reintroduced, this is in Terraform V1, we brought it back in V3, is the ability to go through and say, we want to pre-approve our Terraform plan step before it gets to apply. So I believe this is enabled on this blueprint. Let's not make a liar out of me. Where it's going to go through, it's going to show the Terraform deployment. What's also handy, you'll see here, we'll see the output directly from Terraform. We weren't doing that in the previous version. So we will actually print that output as we're going through these Terraform steps. And when we get to the plan step, we actually have to notice this continue job button is now enabled. This is actually a paused job at this point because I've chosen to force the user to come in and take a look at the Terraform output. Assuming they understand what Terraform output means, they can then go through, see everything that it's going to create, get down to the bottom, kind of see the summary where we're going to be adding 9 things. As long as the end user is okay with that, they can say continue job. This then proceeds, goes out and builds those resources. The other thing that's handy from a Terraform standpoint is the visibility that we have here, where we can go into the log and see the output of our Terraform configs as part of the job logs as well. So capturing all of that, making it visible to the end user, easy to find those types of things. So that's kind of the big picture. It makes Terraform a little easier to set up inside of CloudBolt, or a lot easier to set up inside of CloudBolt. There's also a lot more powerful features we're going to get to later on, but just wanted to show the big idea to start. Now we're going to move on to getting started with leveraging the Terraform operations inside of CloudBolt. So the first thing we're going to do, so for probably the remainder of this video, we're going to be building 1 or 2 different use cases. They're very, very straightforward. One's going to be an S3 bucket, and the other one's going to be a virtual machine of some sort, whether it's an EC2 instance or Azure virtual machine. Maybe we'll go Azure just to show provisioning Terraform on a different platform. But the first thing I'm going to do here, I already have this blueprint created in this environment, but we're going to run through this. We're going to start from scratch. I'm going to go in and I'm going to create, let's say, how do I deploy S3? And that's going to allow me to create a blueprint that we're going to use specifically for this video. I can go in, I'm going to give this a logo real quick, just like to set it apart, usually throw Terraform on there. One of the things I will call out before we get started, one of the differences in Terraform v3 is you now have the ability to set different resource types at the blueprint level as well as at the build item level. So if you can think about this, this will make a little more sense as we show this in the demo or as part of this video, but the blueprint really should represent the overarching thing that we're deploying. It could be an application stack that maybe has multiple state files that represent different things that we've built. So in my case, that blueprint's going to be using my Terraform deployment resource type. That means I can go and look at all of my Terraform deployments and should be able to get to all of them in one view under my resources tab. Those Terraform deployments could include different types of resources. Those resources could be an S3 bucket or an EC2 instance, or the components that are needed to build those things, all included in my Terraform state file. Again, we'll dig a little bit deeper into that as we get there. Just wanted to start by calling that out of the gate. Let's just go ahead and keep this real simple. We're going to start there. I'm going to open this blueprint up to any group can deploy. Then I'm going to go over to my build tab. And the first thing that I'll point out, really the first thing you need to do before you can get started with Terraform operations, is you need to enable them. So I had them enabled in this instance at one point, but I disabled them. So we're going to come over to my command line. I'm SSH'd into that appliance. And what I'm going to do is, instead of the D here for disabling the feature flag, I'm going to use the E switch and I'm going to enable that feature flag. This command is in the Terraform Operations v3 documentation, so you can get to that as part of the documentation. One of the things I will point out here, when you first run this, it may take 5 to 10 minutes until this Terraform Operations button actually shows in your environment. Let's see if mine shows up right away, since I already had it enabled now. So I'm going to pause until it's showing in my environment, but that's kind of the first thing you do, is enable the Terraform feature flag. And there you go. That was fairly straightforward. So it took maybe 2 to 3 minutes here, but the Terraform operation is now set up, and this has enabled all of the features across the platform. So you won't be able to see your variable maps or anything like that until you've enabled that feature flag. Once you have, you can then get started with leveraging Terraform operations. Now that we have our Terraform operation up and running, we see it in the blueprint. Let's just go ahead and build this and kind of walk through the logical process that I'm going through here. Actually, yep, right here. The first thing that drops down. So out of the box, one of the things I'll call out is CloudBolt is currently only shipping with Terraform 0.13.5, really old version. This should be updated in the next release or two, just to get the most up-to-date release. But we're going to walk through how to get the appropriate version of Terraform out there. So one of the other things we did change in this new version is the ability to have a specific Terraform version for every single build item inside of CloudBolt. You can still set a global version for this, and we'll walk through the process to do that here in a minute. But why don't we just walk through? So I have Terraform 1.5.0. Let's go through Linux binary download. I'm not sure what happened there. Let's try that again. All right, so install Terraform. So we need the Linux version because we're installing on a Linux OS. I would go with CentOS or RHEL. Nope, actually I lied. I want the URL. So I believe this is just the binary. So this downloads the zip file for the binary. So I can actually take this link. I'm going to copy the link address, and then I'm going to jump over to, actually I want a different version. So let's go 1.5.1. So I have 1.5.0 on this appliance. We're going to get 1.5.1 up and running. So let's go through the steps to do that. So first thing I'm going to do is I'm going to cd over to var tmp CloudBolt. Nope, I don't want var tmp. I want var opt CloudBolt Terraform. And then if I just do an ls, I can cd to bin ls. Now notice under my bin directory, there's a couple of files here. You'll see this Terraform. This is actually a symlink. And the symlink is used to point at whatever version you've selected the global version of CloudBolt to be. So we don't want to overwrite that. And we have Terraform 1.5, Terraform 13.5. I'm just going to clean up my directory here real quick. Get rid of that zip file. I don't need that anymore. And then okay, now it's a clean directory. We're starting from scratch. I am going to create a new subdirectory because when I extract this binary, it's going to attempt to overwrite this Terraform file. I don't want to do that. So let's do cd tf 5.1. So now that I'm in this directory, you see there's nothing here. I can just do a real quick wget, go out to get that zip file. We can do an ls. There's my file. If you don't have unzip on your CloudBolt appliance, you may need to install it. I think it's just a yum install unzip, but I could be incorrect. Google that one. I know that's what I did. So we're going to do unzip. There we go. And now we have our Terraform. So what I'm going to do here is I'm just going to take this file from this directory and I'm going to move my Terraform file to up one level, and I'm going to call it Terraform underscore, make sure I'm matching the syntax for these, 1.5.1. So I'm moving my file up a level. I'm going to get and clean all of this up. There we go. Now I have 3 versions of Terraform, and I believe this should be fairly instantaneous. I get back over to my blueprint. If I go to my, I don't want that. And this is where we need to mask these, but Terraform Operation, there we go. We see Terraform 1.5.1. So this is how we would reference the Terraform version when we are doing it for a per build item. So if we want to override the global setting for Terraform for the system, we can set it for the build item that we're building out. We can also, if you go over to all admin, close that, we can go to miscellaneous settings down here. And in our miscellaneous settings, we can search for Terraform. Here's our Terraform version. This is where you would set your global version, is under resource management settings on the miscellaneous settings page. We can select 1.5.1. I'll save changes real quick. And we'll actually go right back and verify that that change took place. I should have just typed it. It was way further away. Okay, let's try this again. There we go. Notice our global version is now pointing at Terraform 1.5.1. So we've changed our global version. That would apply anytime that we don't explicitly set a version on a build item in CloudBolt. And what that would allow you to do, if you don't set it on the build item, what ends up happening is as you update Terraform to newer versions, any blueprint that's pointing at that will use the newest version that's available. That could be problematic if you are relying on older features that are getting deprecated in newer versions. So you may want to explicitly specify the version of Terraform Operation so that you can appropriately validate and test as you go through upgrading versions of Terraform on your system. Back over to our blueprint again. If we look at this Terraform Operation build item, you'll notice that the next thing, we'll just kind of work our way down here. I'm not going to fill any of this out because I keep closing it and forgetting about that. We'll do it when we're ready for it. The next thing down that I'll call attention to, again, back to this idea of resource type. So remember we talked about earlier, the blueprint itself under the overview tab can have a resource type set, and that resource type represents the entire blueprint deployment. Now we get down to each build item under the build tab can also have a representative resource type assigned. What I typically do here, and just in the case since we're building an S3 bucket for this specific example, is I will select a resource type of S3 bucket here. And what that does is now I have a Terraform deployment that may include one or more Terraform deployments. And in that Terraform deployment, one of the things that it is building is an S3 bucket. So it allows us to represent things a little more accurately inside of CloudBolt. So if you have ad hoc use cases where there's independent resources being built, you can represent them independently inside of CloudBolt. It really, what happens at the end of the day is you'll have a parent resource that includes then an S3 bucket that's represented by a state file in Terraform. We'll again show what that looks like when we get there. The next piece to this is that confirm Terraform piece. Actually, why don't we go ahead and fill this out as we go through. So let's see, S3 bucket website. We can put a description there. Version, again, I'm going to select Terraform 1.5.1. The reason I'm doing this here is because if we change the global version of Terraform down the road, this will not impact this specific blueprint. we want to control this specific blueprint a little more granularly. Confirm Terraform plan. This is something that was added back in. I showed this as part of the introduction to the video, but here's the toggle that allows us to say, do we want to confirm this Terraform plan, or do we just want to do an auto apply of the Terraform config? I think this option depends on who your end users are. If they're people that understand Terraform and what Terraform outputs are telling them as far as like how to confirm plans, then you probably want to enable this confirm so that they can verify that they're not impacting other cloud-based resources. If this is for a more simplistic end user type use case, you probably want to disable this so that it auto applies. They're not going to know what all of the output from the Terraform plan command is anyway. So we can disable that by deselecting this. So just something there. Let's go through and talk about now. So there's a couple of ways to get Terraform content into CloudBolt. One is we can upload a zip file, or we can reference a Git repository. We're actually going to reference a Git repo in this specific example. One of the other things I will point out here is the idea of a connection info. So in CloudBolt, we have these things called connection infos, and really this is a way for us to store secrets in order to connect to an endpoint. In my system, I already have some connection info set up. One of these is for GitHub. Some of these are for other things. For this specific example, though, I'm not going to set that up, but we are going to walk through how to set that up here in just a second. Because when we're leveraging a Git repo, a lot of times these end up being private repositories. We want to protect access to them. And let's just walk through real quick how we would set up a connection info for GitHub. So if you go to your administration button, you can go to all admin here. Then you can go to connection info under integrations, and under connection info, you can create a new Git connection info, and this kind of walks you through the process. GitHub.com is probably going to be the URL. Protocol is typically going to be HTTPS. Name, I usually, depending on what this is being used for, a lot of times I will have one single service account for GitHub to connect to GitHub. So I would just call this GitHub or github.com, whatever you want to be able to reference this connection info by. The next thing I usually do is put in the username of the account that we're leveraging, and then the auth token that we're going to use to authenticate to that repository. So, once you've done that, you could add a label and a description if you want to. You can create the connection info. And once you've created it, you can then reference the connection info here. So we'll actually go through the process to use a connection info on our second example. But the first example is actually available in a public repository called our hands-on lab repository for CloudBolt. So we're going to use that public repository. We don't need to select a connection info here. And that's how we're going to use it. So we're going to use that hands-on lab repository. I'm just going to bring up the repo real quick. So for my hands-on lab repository, and I'll link this in the video description to this specific repository, we're going to be using this S3 website folder. But first, let's copy the repository URL. From the repository URL, we can fetch a Git repo. We can put the repository URL information in there. I am going to target my main branch, but you can select a different branch here, where if we wanted to target a specific branch, maybe dev or prod branch, those kinds of things. And then we can go through S3 website, and then Terraform is the directory that I'm trying to pull my content from. So what this is a really basic Terraform config that allows me to go through. It will deploy an S3 bucket. That S3 bucket, then it will enable public access. And the reason I did that is because routing's not set up in my lab environment. And it stands up a super simple website that's about the extent of my HTML knowledge goes. So we'll show what that looks like when we get later on down the road in here. But one of the things I'll call out here before we get a little further are the variables here. We are anticipating 3 variables to be passed in. Owner and group are being used as tags for the S3 bucket so that we can manage and track what we're doing, and leveraging CloudBolt to really drive in the appropriate values for the owner and the group of the resource. And then the third piece is really just a bucket name. So this has to be a globally unique value that isn't used anywhere else in AWS's ecosystem. We could put some standardization around how we're doing that and make it unique for CloudBolt. So we're going to work to build out this use case. But these 3 variables are what we're going to need to pass in from CloudBolt to the Terraform config when we're using this. So anyway, the whole point of this here is I needed to get the directory information. I'm going to just copy from the URL here. And we're going to use this subdirectory input here. The subdirectory allows, what we'll do is we'll actually pull down the entire Git repo, but we'll change the directory before executing the config. So we have our subdirectory set. The next thing we're going to do, we're going to get to this here in a little bit. We'll talk through variable maps in a little more detail. We're going to leave that blank for now. And the last thing that I'm going to select here is refresh on order. So refresh on order, this is a feature that allows every time this blueprint is submitted, do you want to reach back out to the repository and get the most recent and up-to-date information from the repo. So I'm going to select that here. I don't think I want to confirm the Terraform plan, so this should be good. If it's not able to connect, either because I fat-fingered something or my authentication credentials are incorrect, it will let me know there, and then I can go back and check everything, make sure that it's set up correctly. You'll notice now I have a build item on my blueprint. The build item, there's a couple of things going on here. We need to do a couple of things before we're able to use this. One of the things we could do here is maybe fetch remote code. That'll reach back out to the repo, pull in the latest version of the Terraform config. There, we've refreshed it even though we just pulled it down. You can also edit this blueprint item and get back to some of those original settings from the pencil here. And really, there's one last thing that we would need to do for this before we're able to submit this blueprint, and that's attach an environment. And we got to do our variable maps too, but I'm going to start by attaching an environment, and I'm going to use one of my AWS environments. In this case, I'm going to use my sales demo environment, and I'm going to select next. This is then going to give me a set of variables that are already set on this environment. Now, this is a little bit different. I think we mentioned this in the introduction, but we can set static values for these. So like if we're asking for a network, I can say predefine the network's going to be this network, and that's the network that we're going to pass into the Terraform config. This allows me to take a set of values that we already know about based off of the region or the VPC that we're deploying to, and predefine where that network target is going to be provisioned to. We can statically set those values here, or we can make it a little more, if we're referencing any of these values, the drop downs will pull in those available values into our plan. And we'll actually show that with a virtual machine instance later, where we'll pull in our instance types directly from the blueprint item parameters here. So we then do next. And once we do next, we now have an attached environment for this S3 bucket website build item. Now that I have my environment attached, now we're really, this is set up to start using, but I haven't told it. Remember, let's go back to our config. Remember, we have these 3 variables. So if I were to submit this today, the build's going to fail because none of these variables have defaults set in my Terraform config. So one of the things you will want to know, if there are defaults set here, just like if I were running things in the command line, it would go through and apply the defaults. So if you wanted to use those defaults, you would specify them here and then not pass in a variable map as part of this. So so these variables, we need to get to a point to where we're passing these 3 variables in. And the way that we're going to do that is with this new feature that we call variable maps. Now, I showed this real quickly in the introduction. We're going to go back on over to variable maps. There are 2 variable maps that are available out of the box today in CloudBolt. One is the AWS to Terraform variable map. And what that does, remember we just mapped an environment. That takes from our environment, it will get to the resource handler, and then it'll pull in the appropriate values for the access key and the secret access key. This way, your end users never have to know credentials to your AWS accounts. We're leveraging that shared service account connection to get it over. So just by selecting this AWS to Terraform variable map, we know that we're going to inject those variables in at runtime to the Terraform command line as local variables. So these two are out of the box. There are probably a couple others that we'll add over time, maybe one for VMware, one for GCP and other clouds as are relevant. Azure, if we're deploying to Azure, that you would select this variable map, and vice versus AWS, we're going to do things for that enterprise account that you've configured to set up as a connection to Azure. But really what we're going to focus on here, because we're going to use this for really any AWS workload, I'm going to focus on my S3 website inputs. This is something that I created for this specific blueprint, where you'll notice we have our owner, our group, and our bucket name variables declared here inside of this JSON payload. So I'm going to launch my S3 website inputs variable map. I'm going to edit it. And you'll notice here, this is pretty straightforward. I've actually specified in double curly brackets. So if you haven't watched these videos before, what this is called Django templating. The CloudBolt application resides on top of the Django web framework. So we are actually telling the system that this is not just a map of variables, but it is a templated map of variables, which makes it extremely powerful. I have told it that I want to use a parameter in CloudBolt called S3 bucket name. There's an order of operations for how we're going to get to these. We're going to cover those to an extent today. I'm also going to, let's look at this. So my owner and group tags, I don't want to just statically pass this in. I can. So if I have a value that I just want to statically pass in, you could just put it in quotes, and that's going to statically pass those values into the Terraform config at runtime. However, what we're going to do is I want to make this a little more dynamic. I know the owner because I know who's submitting it in CloudBolt. And I know the group because I know the group that submitted this request. So let's go through and just map those values out so that we can pull those from the runtime context in CloudBolt and pass those into the command line when we execute the Terraform apply. So when we talk about these templates, there's a number of things that get passed in. Number one, if it's something that's just referenced as just a name and it's not something else that we're using as part of the templating process, it will first look to see, is there a parameter in the system that exists called S3 bucket name? And if that parameter exists, it's going to use the S3 bucket name logic that's been defined. That could be dynamic dropdowns that we've configured that are using generated options for that specific parameter. It could also be values that are set at the environment level from the environment that we're referencing. So this parameter would need to exist before we're able to use it here. So you can create your variable maps, and then you can go over and create your parameters if they weren't pre-existing. But then the next two, so let's start with group. Group is pretty straightforward. We do pass the group into context, and I could go through, actually, you know what I'm going to do? I'm going to do group.name. I could do just group, but the way that my environment's set up, it's passing multiple levels of the name in. I want the name of just my subgroup, which should be, if I'm submitting it for my IT group, should just be IT. I also want to capture owner, and this one was a little trickier. I don't know all of the things that we're passing into context quite yet, and I want to work to get those in the documentation. But we do pass in what are called blueprint item arguments, and we pass them into something called BIA. So a lot of the things that you are able to get to in the context here would be starting with the blueprint item arguments. So I'm going to start with blueprint item arguments. You could also reference the blueprint and pull some information from the blueprint itself. I'm not going to do that. I'm more interested in my blueprint item arguments. I'm then going to get to my blueprint order item, which is tied to that. And that's really the information that was passed in from, the blueprint item arguments are the arguments or the variables that are passed in from the user. This is tied to a blueprint order item, which is the actual build item on the blueprint that we just created. So the blueprint order item then ties to a specific order. That order then has an owner, and my owner has a full name associated with it. So kind of a long process to get that drawn out. I'm already talking to the developers about hopefully making this a little shorter and getting it. I want the resource object passed in here so that we can shorten that process up a little bit. Makes it a little more straightforward. Anyway, so we can get to the owner, we can get to the group because we already know these things. We're not going to prompt the end user for them. However, for S3 bucket name, we are going to prompt the end user. So I'm going to go ahead and save my S3 website inputs. Like I mentioned, this parameter already exists inside of my environment. Why don't we just take a look at that real quick? Here's my S3 bucket name parameter. You'll notice I haven't really done anything. Why don't we do some constraints here just to show that they're taking place when we get to Terraform. So let's say minimum length. I want to make sure that this is fairly hard to, we don't want them to run into duplicate name constraints. So I'm going to make it pretty long length for a bucket name. Maybe, and I don't know if there are any maximums on S3 bucket name lengths, but maybe referencing the AWS documentation there. I'm going to put a little constraint here that says min and max length so that we're checking those. We could put placeholders and descriptions, and maybe we say, maybe CB dash how do I dash 00001. Just something to give the user kind of a shadow value that they can copy from. So that should be enough just to show that this parameter is pulling some of those things into our form. Let's save our parameter. Let's go back over to we have our variable maps now, we have our parameter. And then if we go back to our blueprint, I'm just going to launch this environment just to show this parameter does not, so that S3 bucket name does not currently exist on this environment. So that was something else in the last version. We had to first create the parameter, then tie it to the environment, then go through a mapping process for every single one of those. It doesn't even have to be on the environment anymore. The only difference is that if it is on the environment, we will take the constraints that are filtered down to the environment level. So just keep that in mind as you go through this. From here, let's go over to our catalog. Let's get back to our S3. How do I deploy S3 blueprint? And I'm going to order. Let's see how things go. I'm going to deploy it for my admins group. There's the name of it. And it's not prompting me for, I should be prompted for my S3 bucket name. Let's head back over here, troubleshoot this a little bit. So let's kind of work down the path that we need to get to. Here's my environment. Oh yeah, I wonder if my group, my admins group has access to that environment. Okay, so it should be available to all groups. That's a good start. Again, no parameter set here. So we have an environment attached. Oh, the last thing, the thing I forgot at the very beginning. I didn't see any inputs because I haven't mapped my variable maps yet. So let's come back. Notice our variable maps are empty. So first of all, for authentication, anything that's deploying AWS resources, you want this AWS to Terraform variable map. Second, S3 website inputs. Without these maps, we don't know what variables we're trying to map into your Terraform configs. So let's go ahead and save this. There we go. And we should now be able to go back to order and see that that is now an input parameter. Notice it's pulling in some of that logic that we defined. So there's our placeholder here. You'll notice it pre-selected that environment because it's the only one that's available for this blueprint. If the user had access to multiple environments, they would be able to select from each environment, and that would allow them to leverage the credentials that are set on the environment, plus use any filtering that kind of goes down the rabbit hole as we're referencing those variables on those environments. But here's my bucket name. Let's do cb-how do I-00001. And let's submit and just validate that this process is working. Okay, so here's the output of the plan. And remember, I did not say that we were going to force this to go for approval. So it showed us the output of the plan. It's now completed with apply. And what we have left now, here's our 3 jobs. We could dig into our Terraform job if we need more information there. I'm actually going to go to the resource first. So remember, we have multiple different resource types. So our parent resource is called How Do I Deploy S3? It probably doesn't make sense for a production deployment, but we can name the resource. I would probably, for production, I'm going to probably standardize my naming standard for this S3 bucket and use that to name my parent resource appropriately. From that parent resource, so you'll notice that I have sub-resources available, and the sub-resource that exists is my state file now for that build item here. So I have a state file now that's representing what Terraform has deployed. We can go over to my output tab. Notice my output tab shows my entire Terraform state. So if I understand Terraform and I need to get that information, I can view everything that we've enabled them to view. Some of these may be marked as like sensitive and things like that. But we now have our output that's been defined here. No parameters yet. We're actually going to build towards taking outputs from Terraform and using them as CloudBolt parameters as part of a follow-on video. But from the output, I can go through and see, let's see, here's my website endpoint. So here's my value for my website endpoint. I can now go out and validate that this website does in fact exist. Here's my super cheesy sales engineering level HTML website. This is now a public facing website that was spun up in a matter of seconds from a Terraform config. So pretty easy to get through all of that. So that was pretty quick to get that stood up. And this could get pretty, when you're starting to work with Terraform, there may be many variables and dependent variables, all of those kinds of things. CloudBolt can help with that, because we can dynamically generate those inputs. We can set up basically allowed values that are allowed for each of those inputs. You can constrain what the end user is able to input. You could also, a lot of times we'll use this even for something as simple as an AMI image ID versus the end user having to know the AMI ID for the exact correct image in the right region. We can set up a standard behind that, and that way we're driving the AMI ID intelligently inside of CloudBolt. So yeah, why don't we, I'm going to pause real quick and get set up. We're going to go into one more example, more of a server-based example to wrap up this video. I'll probably have this set up and just run through some different ideas for things that's just a different kind of resource type. So I'm going to pause and we'll be back in just a minute. I have my EC2 blueprint set up now. There's a couple of things I'll point out before we dive into this a little deeper. Very basic EC2 Terraform config, just for a kind of base EC2 server. So I wanted to show, so this is inside of a private repository. So one of the things we didn't cover earlier was just that connection info. So we did point out the connection info, how to get those set up, but you'll notice here that the big difference is that I'm referencing that connection info on my build item, and that provides authentication. If you don't provide authentication, or you use an old token like I used the first time through, that actually gives you an error message just stating that the token's wrong, or something in your syntax is somewhere in here is incorrect. So what we have going on right now is literally just that AWS to Terraform variable map. Super basic, super straightforward. There's really not a ton going on with this. I'm not even passing in any variables in this current state. We'll build this a little bit as we get into this, but just to show kind of the process for an EC2 instance, it will reach out, execute the Terraform config, go out and build that item. It's going through kind of doing that same process we did with S3 earlier. The big reason I chose EC2 though, is that EC2 is a little different in that in CloudBolt, we actually ingest that or create a server object in CloudBolt that represents that EC2 instance. So you can take and manage, you can leverage CloudBolt with Terraform for provisioning and deprovisioning, but you can manage day two a little more intelligently with built-in CloudBolt day two action. So at this point, my Terraform Apply is complete. I now have an EC2 instance. We're on the job for the Terraform build item. I'm going to go back just up a level to my blueprint item or my order item where I can get to my parent level deployment. Let's just take a look at what this looks like. So remember, we have a parent Terraform deployment. In that Terraform deployment, we then have a state file that manages what is going on in Terraform here. We can take a look at the output here of my state file. And you'll notice that associated with the state file, now we have a servers tab that's available. This is a very basic server. The out-of-the-box behavior today is that we will create the server object, and then once your inventory refresh runs with a scheduled job in CloudBolt, we'll ingest this to pull in a lot more usable data from the cloud endpoint. Right now, I can't really even do anything with it. It wouldn't let me refresh info, things like that. I'm actually going to do, I'm planning, we'll see how time works out, but I'm doing a second, more advanced Terraform series where we can get you some code samples to create this object at runtime so that it's just as if it were just inventoried by the inventory plan. So the big reason that I like to do that is that we can now take that EC2 server instance and leverage it as part of additional automations downstream. So things like Ansible or Chef or Puppet, some of the other configuration management technologies that we connect to, you can now take the server and consume it in those configuration management lifecycles, just like you would if it were a server that were deployed by CloudBolt's server provisioning out of the box. So allows us to take action against this server, maybe run scripts against it, things like that, after a Terraform config is responsible for first setting it up and deploying it inside of your environment. So pretty powerful stuff. But the reason that we're here today is not for that. I'm going to go back. So just remember, we're at the state file now. And from the state file, I can get back to my parent Terraform deployment. I don't think we've shown a destroy yet, but similar to provisioning, if we go through, I'm going to delete you want to delete the parent object. So I'm going to delete this Terraform deployment, and that's going to clean up my deployment. It's going to clean up my state file. It's also going to get rid of the server object. So we now have this delete job that's gone out to deprovision that EC2 instance. And if we dive into that sub job where we're doing the destroy for Terraform, we should see there's our init step again. And we should see that it's now going through a destroy process. So we'll give that a few seconds to update and refresh. All right, so this is now finished, and we have the output. So you can just like with the other jobs, we do see the output of the destroy. So we're able to view that everything was cleaned up. It's no longer inside of our AWS accounts. Yeah, so full life cycle for Terraform. Let's go back now. So I do want to expand on this a little bit, and I'm going to dive a little bit deeper into EC2 here, this sample that we're working with. Let's take a look at, so let's go back to the build item. We're not driving any parameters today. So I'm going to build this out from scratch. We're just going to kind of go with this in the recording, but let's start here. See if I can get this full screen, and then we'll be on our way. Okay, so here's my Terraform config. These are all really straightforward inputs. I didn't pass in any variables, and I didn't have to because I have this, I have my variables, my default set in variables. So it already knows a lot of this information, but why don't we go out and build a new variable set to match most of these, maybe not all of these, but let's go ahead and match most of these. Let's go through and get to, trying to remember where I was at. Okay, so I'm going to cheat a little bit. I'm going to take my default variable map, or my last variable map that I was using for the S3 instance, and just kind of copy that because I already know that owner and group are two of the other tags that I'm going to pass in. And since that's kind of my standard for my environment, I want to know owner, I want to know group. I can easily, actually, you know what I'm going to do here? I'm going to create a new variable map, and I'm going to call this tags. And this is going to be, let's call it AWS tags. And what we can do here now is we can take my owner and my group, and we can create a reusable variable map that can now be shared across different Terraform configs. So what I should need to do, and let's just validate that this works with S3 first. I'm fairly certain it will, but I always like to trust but verify. There we go. Now our S3 website input, we've kind of split things out a little bit because we're already seeing commonalities across our different Terraform items. So now I can take my AWS tags and I can have one single variable map that defines all of my AWS tags. As long as I'm accepting them in my Terraform configs, we always know that those tags are getting applied appropriately. So I can go back over to my S3 blueprint. I can update my variable maps now on my build tab. I'm going to include now my tags. I can save. Now we should be able to redeploy a new S3 bucket and see that those tags are getting applied as expected. Random number, make sure that that's unique. We should be able to see it in the set progress window here. No, that's not super pretty, but it'll be done in just a second here. So let's go over into our S3 bucket, just validate that our tags are showing the right values. They should be. It didn't complain, so I'm assuming that that worked as expected. And here's my how do I bucket. And if we go over to properties and we look at our tags, we can see group. This request is submitted for the admins group, and owner is Michael Bombard. So we're able to view the group and tag. So again, just another example of a good way to use variable maps in CloudBolt is to split them out into individual use cases that can be reused across different Terraform configs. So now that if I've standardized my Terraform configs to take in these two tags on every single Terraform execution, then we can just apply this in the AWS to Terraform variable map, and we're off and running with a lot of the variables that are required out of the box. So let's go back to just going to open my how do I EC2. And I'm going to, let's just start here. I don't need to take my owner and group now because I already know them. But my new variable map, I can do EC2. Let's just keep it Pythonic. EC2 inputs. And I can split screen this here if it'll let me. Let's see if I can get this to work. There we go. That's better. That's what I was hoping for. Okay, so now we have owner and groups already taken care of. AMI ID and subnet ID, I'm going to leave for a minute. I'm just going to update instance type and EC2 name. So I want to add those two as inputs. I don't like to boil the ocean. I want to make sure that this is done right. Make sure this is valid JSON. So instance type and EC2 name. Instance type is actually an existing CloudBolt variable. So I want to make sure that I capture that correctly. I want to make sure I'm using the right name. So if I go into my sales demo environment, I can go to parameters and see, here's my instance type parameter. Here's the actual database name for it. So instance underscore type was correct. I would rather verify be proved right than to test it and be proved wrong. So instance type should already exist. EC2 name is probably not something that exists inside of the system today. We'll check. I don't think that exists. I mean, maybe we don't call it EC2 name. Maybe we call it server underscore name. And then we can use the same parameter for AWS and Azure and kind of use it, make it a little more global in our system. I'm just going to kind of stick with what is set in the Terraform config. Now I'm going to do this, and I'm going to mess this up on purpose. I'm going to go ahead and I have my environment attached. Let's make sure that we get our right variable maps attached here. So we need our AWS tags, and we need our EC2 inputs. So now by saving this, I should be prompted for an instance type and an EC2 name. So I go to overview and go to order. Notice I'm only seeing instance type, and this is kind of what I was expecting. We'll talk about this behavior a little bit. EC2 name does not exist yet. It's not a parameter in the system. We talked about this earlier, but we didn't actually go through with creating it. So let's go ahead and create our EC2 name parameter. I have my parameters tab open. New parameter, call it, let's just call it name, and then EC2 underscore name. Actually, we can EC2 name. I'm going to make this a string. I'm going to make it required. I could put constraints around this as well if I wanted to. Show on objects, I think should be okay. And then we'll save this. Let's just make sure I'm not missing anything else. Once you create the parameter, you get a couple more options available in here. I could set up some constraints, those kinds of things. I could set up some like dynamic drop downs with programmatically generated options, those types of things. Not going to do that. We're not going to go crazy on this call. But this should be good to go now. So if I go back over to order my blueprint and refresh, notice our EC2 name field is now available. It's set as required, and we should be able to input this EC2 name as needed. The other thing I'll point out is this instance type. Remember, we talked about the propagation of parameter values in the last section of the video. When you tie an environment to a CloudBolt Terraform Operation build item, that environment now has some of these values. So if these parameters or these values are in the environment, we will take the values that have been pre-selected for the environment and use those as the available options in this dropdown. So be mindful of that. This is part of that propagation where, because this parameter exists on the environment, the only options that I see here are going to be the instance types that have been predetermined to be available for this environment. So it allows us to control things a little more tightly. One of the things I like this for is instance types in particular. Most organizations only use a smaller subset, maybe 20 to 30 different instance types. And I think presenting all of the available instance types in AWS can lead to some confusion and just make your deployments a little more challenging. So we can constrain this and make it a little more user-friendly so that they have a smaller subset of sizes to pick from. There's kind of a hidden benefit there. We can actually use this when we start to talk about cost and cost advantages. We can help you increase your purchasing power by constraining the number of instance types that are available on the front end. So just making that process a little more user-friendly, make your purchasing power increase when you look at reserved instances and things like that down the road when you go to provision these things. But if you recall, my default was a T3 micro, so I don't want to do that anymore. I'm going to do a T4G. Let's do a small. So we're going to see our size change, and then I'm going to actually input an EC2 name. So let's say there we go. Fake name. So we've now taken a Terraform config and kind of leveraged it using reusable variable maps to drive our tags in. Those tags are pulling in well-known values that CloudBolt knows about. And it should be passing those values into our Terraform config here, where we're now able to see that. Oh, and something did not work. So maybe we missed architecture. Oh, so here's where I believe my instance type was incorrect for the AMI. So when you build your environments and you constrain your environments, I selected the wrong instance type. So I'm actually, those T4G are not good instance types. So I'm going to go back to my environment and fix that real quick. So here we have all of these instance types. I'm just going to reload all of the instance types from AWS. So this pulls in the most up-to-date instance types. I'm then going to edit this. It's the T4G series, or ARM processors, I believe. And that's part of the challenge, right? You start to, your end users don't know that. So that's when you're building out a service catalog, that's kind of what you want to pay close attention to, is making sure that the right sizes are available to the right people at the right time. Okay, so that should be all of the T3 sizes that we want. Let's go ahead and save this. So now my environment's been updated, and those options should be reflected in my blueprint when I go to order it. So let's go back over to my catalog, find our how do I EC2. Let's go back to order. Again, see those options have been updated to reflect. We're going to do a T3 small. And let's submit. There we go. We're getting our init step. It should move into plan here shortly. So let's see. So T3 small. So notice that value is passed in, and you can see my tags here as well. So it's passing in those values from our parameter sets, or variable maps. Sorry, this is new terminology that I'm still trying to get down. But we can see now we've built an EC2 instance. Just I like to go back through. Let's go over to EC2 and just check this in the cloud and bring things in for a landing for this video. So let's see, instances running. There is my new instance that we just provisioned. We can click on the instance ID. We can see that those values were passed in. Let's see if we go to tags. Here's my name. Here's my owner and group. So yeah, so this is now up and functional, and you know, we have a new blueprint that's been used from an existing Terraform config. We've expanded that to take in intelligent inputs. As part of the next video, hopefully we get there within the next couple of weeks. I hope to dig in a little more, because we want to show how to control AMI IDs. We want to show how to control networks and just more intelligently drive those as well, because that's a big part of the picture and the puzzle as well, is ensuring that we have the right AMI IDs, the right subnets available to the right users. So that's all part of a follow-on video. So I think that brings us in for a landing for today. So again, the big thing here, I think we covered a lot of these variable maps. These are a really powerful feature, and you're going to start to see these across the platform as part of being consumed in other contexts as well. This concludes another video in the How Do I Do Something in CloudBolt video series. If you've made it this far, congratulations. Some of these can get to be a little bit lengthy. If you have any questions at all regarding anything that we've covered today, or really just anything about CloudBolt in general, please reach out to your account team. We're happy to cover any questions you may have, and we're always looking for additional ideas to cover as part of this series. So please reach out to your account team. Let us know how we can help you, and happy automating with CloudBolt.